Hello and welcome to today's class. Check out this radical equation. We can solve this radical equation or this kind of radical equation using two different methods. We can either move this quantity to this side, then square both sides of the equation, and then we simplify. Again, we can equally square both sides of the equation, and then we simplify. I prefer squaring both sides of the equation straightforward. So how we solve this, let's take our selection first. All right, so we take our question here. Like I said, I want to square both sides of the equation and see what that gives us. All right, so this is going to give us the square root of minus t, then plus the square root of t, all raised to the power of 2 equals to 2 to the power of 2. Why are we taking the square of both sides? Because we're having a square root radical here and a square root radical here. Okay, all right, so with this, if we open up this expression, remember the expression which says that when you have a quantity of this kind, if you have your x, let's take x, then plus our y, all raised to power 2, this is equal to our x to the power of 2, then plus our 2xy, then plus y to the power of 2. Remember this? Good. So with this, we can rewrite this side of the equation. This side doesn't have issue. This side is just 4. Okay, this side of the equation is just 4. So this is going to give us the first term, which is the square root of minus t, right? We said all raised to the power of 2, which is this. There's plus our 2 times the square root of minus t times the square root of t, right? Of t. Okay, then plus our square root of our t all raised to the power of 2 equal to our 4. Right. Now, this we go with this radical and this radical we go with this. We all know that? Right. So this is going to give us minus t plus our 2 because this is square root radical, square root radical. So according to the law of surd, two of them can come together. So this gives us our minus t times our t, right? Then plus our t equal to r4. We're having minus t plus t on this other side. So this and this can leave the system. We're now left with our 2 into the square root of, if we multiply these two together, this is going to give us minus t to the power of 2. This is equal to r4. Here, something is playing out. We can divide through by 2. Okay? So this will now be divided by 2. We equally divide this by 2. This leaves 2 here, 1, 2 here, we have 2. So we're now having the square root of minus t to the power of 2. This is equal to r2. Now look at this. Here comes a little confusion, but it's not a confusion by the way. Now look at this. There's a video I made on this channel where I said if you have minus x to the power of 2 is not equal to your bracket minus x all raised to the power of 2. These are two different entities. Okay, so if there are two different entities, it means we can rewrite this expression we have here in another format. So this minus 1 is standing on its own, so we can rewrite this as our minus 1 then times the square root of t to the power of 2 then equal to our 2. Now recall that the square root of minus 1, the square root of minus 1 is equal to our positive iota, where iota is imaginary, right? So if we bring that into the system, this will give us something unique, right? So this is going to give us our iota times the square root of our t raised to power of 2. Again, the square root of t, this can go with this, but let's just continue first and see. So if we do this, what happens? This will go with this. I'm going to have iota times our t is equal to our 2. Okay, it is not it, all right? This is iota times t. So let's divide by iota. We equally divide this by iota. This leaves. So now having our t is equals to 2 all over iota. Simple, right? Good. But we have to do something. We have to kind of eliminate this iota at the bottom. And so we multiply everything by 1. And 1 is the same thing as your iota all over iota, right? So this will now interrogate us 2 all over iota times iota all over iota. So if we continue in this is going to give us 2 iota all over iota to the power of 2. Look at the relationship we have here. If we decide to square this part like this, and we decide to square this part, so this is going to give us minus 1 is equals to iota to the power of 2. Okay, so we are having here iota to the power of 2. So we can bring in minus 1 into the system. So this is going to give us our 2 iota here all over minus 1, which is equivalent to minus 2 iota. Right? Good. So we now have here, therefore, our t is equal to minus 2 iota. Wow. So this is the value of our t. So if we substitute this into the system, that will give us our positive 2. And again, having this as one of the roots, so positive 2 iota will also be a solution. So we also have t will equally be our 2 iota. So these are the 2 roots that actually satisfy these radical equation amidst the millions of infinite solution or roots to this challenge. So this brings us to today's smart class, and thank you for watching. We'll see you in our next class.